All right, so this is Linux Basics. It's super basic. I didn't spend very much time on it. I just kind of pulled it from what I knew, so I apologize for the brevity. So there will be time for questions at the end. So if you can just hold them as you just write them down as you come up with them, and we'll go from there. So no, I don't want to, but I will because you kind of need to, right? Screen sharing. Okay, so you guys should be able to see. Can you see it now? Clinton?
Yes.
Awesome. All right.
Yep.
So Linux Basics for Fun and Profit. That's the name. So history. Linux is originally written by a Finnish dude named Linus Torvalds. He posted to the Minix use group that he was creating like a Unix-like kernel clone, a Unix or a Minix clone, and he's like, "Oh, it's not going to be big like GNU or anything," and it's actually pretty funny because it turned out to be like the most popular operating system in the world, believe it or not. Super colorful character. The whole development history has been filled with drama because he's like super like opinionated and hard-headed and hard to work with, and he's like basically ran Linux up until like the past couple of years, where it was turned over completely to the Free Software Foundation. So super interesting history. Now, when you talk about Linux, there's actually like two flavors of Linux. You have the Debian-based distributions and the Red Hat-based distributions. Your Debian-based distributions are like Ubuntu, Raspbian, Mint, Kali, Parrot, and Opix, and there's lots of others. And they use the apt packet manager or dpackage, which is like .deb files. Ubuntu is probably the most popular Linux distribution as far as install base, but the other one, the Red Hat based distributions, are actually probably more prevalent in business settings. So you have like Fedora, Red Hat Enterprise Linux, which is called RHEL, CentOS, and they use the package manager that has like RPM files. So definitely good to keep aware of which flavor of Linux you're in. So the kernel, the Linux kernel is the interface layer between the hardware and your user space. It's like your hardware abstraction layer, or HAL, in Windows. It sits between the hardware and your GNU utilities, your user space programs, your processes. It's sometimes called GNU Linux because of all the GNU utilities like bash, grep, sed, awk that run on top of it. So these are the same utilities that you would find in like BSD, like FreeBSD, OpenBSD, and other original like System 5 Unixes. So a good like visual representation of the Linux kernel. You have your hardware at the very bottom. You have your Linux kernel, which talks with your like devices, has your network stack, your files, systems, and then they do like what are called System 5 syscalls to your processes, which all your inter-process communication is exactly clones of the actual original System 5 Unix distributions. So kernel modules are kind of like drivers in Linux. They're loadable, unloadable, and you can insert them into the kernel for your different hardware. One thing to know if you've ever like manually installed the NVIDIA package is that you need your kernel source to compile the actual kernel modules. So you basically compile your kernel, and then you can write pluggable modules for it, but you do need your kernel source code. So in Linux, everything is considered a file. So all your memory access, your physical drives, your actual files, everything is considered a file, which is unique in like terms of an operating system. Objects can be operated on using the same utilities that are used for files. Each item, each file has an inode number in the file system. And like I said, devices can be represented as file-like objects. So like basically every, even processes are considered files. So it's a really interesting design concept for operating systems. Before Unix, it was kind of unheard of. So that your Linux file system, just like you'd have NTFS or FAT32 on Windows, we have different file systems on Linux. Most common are right now are probably ext3, ext4, and ZFS. And the Linux directory structure is an inverted tree. So you have the root directory at the top, which propagates down to your like etc, your user, your home directories, and from there you have your subdirectories. Common directories are dev for your device configurations, etc, which does all your configuration files. User is user-related stuff. Bin, binaries. Var, that's where your logs are. Your home directory, like home, EC2 user, where your all your user directories are. Then root, which is outside that home directory, and then op, which is for like optional software. So there's users and there's groups. You have normal users and your root user. Root user is ID 0 in etc password, and we also have groups that are used to share access to resources. Whenever you create a new user, it also creates a group with that same name and puts it in etc group. So that's interesting. But you can create your own groups to share resources inside the file system. So permissions, this is probably one of the more complicated things to get your head wrapped around in Linux. So in Linux, there's like 3 different sets of permissions. You have your permissions for the owner, you have your permissions for groups, and you have permissions for everyone else. And they use R, W, and X to specify the read, write, and execute bit. So like, for example, most of these directories have read, write, execute set, and then read and execute, and read and execute. So it's for user, group, and then everyone else. So right here, it kind of shows you when you do an ls-l, this first character is D, meaning it's a directory. Then you have your permissions for your user. You have read, write, execute, which means you have full permissions. And then here you only have read and execute, which means the group and everyone else can't write to the desktop. So only AK Clark, the user, has read and write access to these folders. So you can actually change permission on folders by using the chmod command. For example, if we ran chmod 700 on the desktop directory, you'd see it would change the permissions. So it would give us full access to just the AK Clark user, no permissions for the AK Clark group, and then no permissions for everyone else. So that's how you change permissions in Linux. Processes, just like in Windows, processes have a process ID. You can list processes using the ps command, and you can even kill processes. The process ID 0 is like swapper or sketch. It's actually not a user space process. It's part of the kernel, and then it spawns PID1, which is usually sbin init. PID1 is your first user space utility that's spawned from the kernel. So you can see when you do a -ef, you can see its parent process ID here and its process ID. The parent process ID is just the ID of the parent of this process, if that makes sense. And that was a very, very quick introduction to Linux. I apologize it was so short. I can create more advanced ones in the future. At this time, do you guys have any questions?
None on this side.
Fair enough. Jakari, Clinton, and anything?
No question.
All right, awesome. So I'm gonna stop the.
Good one,
Stop the recording 1 second. Oh man. Stop screen sharing. And then